Hi, my name is Nilesh, and this is a short presentation on our research on optimal real-time multi-agent planning and control for dynamic intersections, which we have called GameOpt. So let's first take a look at the structure of the problem we are considering. The intersection is a four-way intersection with three incoming lanes on each road. All the vehicles we consider are connected autonomous vehicles, and as long as they are in this blue control zone, they can communicate with a centralized control tower. The goal here is to maximize the throughput through the center of this intersection and allow the vehicles to have safe trajectories through this intersection while minimizing the amount of delay and congestion they face. The system we introduce, called GameOpt, is a hybrid system that combines the capabilities of auction mechanisms with an optimization approach to generate the safe trajectories through the intersection. So if we bring our attention to the figure at the bottom, we'll see that the first step is to compute the input state, where all the vehicles in the control zone will talk to the control tower and get information as to their state and their position and velocities. And then this information is provided to the auction-based bidding system, which generates the best sequence in which the vehicles should enter the junction. Then the optimization system takes over and computes safe trajectories that will enable the vehicles to merge in the sequence given by section B. And finally, those trajectories are fed to the low-level controllers on board each of the vehicles so that they can execute the plan given to them. Overall, we find that the system was able to achieve guarantees in safety, efficiency, and fairness for all the vehicles, and we are able to do this while enabling real-time operation. We also are capable of handling dynamic unbalanced traffic, and that means that the traffic on each of the incoming lanes can change with time. And also we do a separate section of multi-lane conflict resolution, which allows different vehicles on different lanes to enter the intersection at the same time, as long as they don't have a conflicting collision trajectory. We evaluate our performance on the SUMO simulation platform and show that this leads to increased throughput, reduced time spent, and reduced fuel consumption in comparison to some existing real-time methods available today. Here we see an overview of our system running, and here we compare GameOpt with traffic lights, which is a well-established structured system for signalized intersections. And if you pay attention to one of these incoming lane sections, you will see that GameOpt results in far less queues and congestion when compared to this traffic light system. And note that both of these systems are operating with the same input flow rate, so the same number of vehicles are coming into the simulation. Here we compare GameOpt with an auction method. So this is a method that can be used in unsignalized intersections, but it would require all the vehicles to come to a stop at the intersection, then decide who gets to go, and then each person starts its journey across the intersection. Of course, again, once more, if you look at the input lanes, you'll see that there's a large amount of queuing and congestion occurring in the auction system, while we see none of those conditions in the GameOpt system.